And welcome back to College Algebra. We're going to talk about section 1.5 today. 1.5 is often one of the least liked sections among my students, just because in math, really for the last 40 years or so, there's really been a stigma against word problems. That's unfortunate because it's kind of where the rubber meets the road with mathematics. Because the only people who are paid to do abstract problems, solve equations, x plus 7 equal 4, are mathematicians. Everyone else has to actually apply the work to something. And that's where application problems, modeling problems come in. So, one of the difficulties of teaching this to students is that it's not really a step-by-step process that you can outline for every problem. Just because every mathematical problem you encounter in the real world is probably going to be different. So, it's more a problem-solving technique. You basically just see what tools you have available and see what will work for your situation. It's like if you're a carpenter, you only bring out certain tools for certain problems. Same thing with solving mathematical problems. We have a bunch of tools. You just have to see which one fits the situation. So let's see here. I'm going to go out through some guidelines. There's a version of this on the I think maybe the first page, but it's really early in 1.5. The first step you should follow is just read the problem through all the way. A lot of my students come up to me with questions that really could be answered if they just read the problem through completely, including, any extra instructions that might be for that section. One of the most common errors students make, and honestly I make it from time to time, is to jump into the solving process before I finish reading the problem. Because sometimes you get a bit of information and you think, oh, this is going to be an area problem. I should set up an area formula. Well, finish reading the problem and see if that's what they need. If not, you need to try something else. Okay, once you've read the problem through, then you need to identify variables. So the first thing you should really look at is, what is the problem asking for? Because usually that's what you're going to set a variable to, especially in algebra. You might actually have several unknowns, in which case you might want to assign multiple variables. Sometimes we do that, but most of the time we'll just assign one. And this is a good point. You don't always have to use x or y. Sometimes it's better to use something more descriptive. If you're finding a speed, why not use s or v for velocity? If you're finding a time, why not use t? Now, the hardest part for students, because this is where you take your math and apply it. You have to translate the problem to algebra. And that's almost always a matter of taking given information and turning it into an equation. Now this is the hardest thing, and it irritates students to no end, because I'm explicitly slowing down your problem-solving process. A lot of you can do a lot of these problems entirely in your head, and that's great. But these are simple problems, at least the ones we start with, and I want you to hone your process to the point where you can do difficult problems. To do that, you need to be able to do several things. One, you need to be able to communicate your process. You need to be able to evaluate your process and then improve it. And what students hate is that I take this process that's in their heads and make them put it down on paper. And I understand. I get it. It's frustrating to have to be able to explain something that you already do. But it's important that you be able to put it down on paper for these reasons. If you can put it down on paper, you can communicate it to somebody else, which is a big thing. One, you can help others. Two, really one of the main differences between a boss and a grunt worker is the boss can explain how to do something, whereas the grunt worker just knows how to do it. You can evaluate your process, which means if you look at it, evaluate an improvement, which means if you look at it, a lot of times you can see where you can improve your process. Because if it's all laid out for you, you can see the big picture. And third, I guess I can add some extra things here. You can check your work much easier if it's all on paper, because you can see the entire process and you can see where it might have went wrong. And once you've got it all on paper, it's easier to understand the big picture and then take it and apply it to harder problems, especially when you've got multiple parts. Multi-part problems might ask you to do several different things, which you could do all individually, but you get lost when you try to do the bigger one. So get used to putting down all your process on paper. That is an essential algebraic skill, and often my students that show the most improvement from beginning to end of semester are the ones that went from showing no work to showing all their work. Alright, once you've done that hardest part, because that really is the hardest part of the entire problem, then you get to the easy part. You'll have some equation, and you'll just solve it, check it, and then at the very end we should make some interpretation. Because, you know, once you solve the equation, you'll get x equals something, or y equals something, or t equals something. Well, if your instructor then asks you, what is x? Well, he's not meaning what's the numeric value. He means, what is this answering? And you need to know that if you're doing a problem, because, I mean, that's the whole point of solving it, to figure out the answer to some question. Well, you found the answer, but you have to interpret it. I mean, is it a speed? Is it a amount of money? Is it an amount of sand? You know, something. So we'll interpret our answer at the very end. So we're going to dig right in. The first set of problems we're going to look at are all just going to ask us to express the given quantity in terms of the indicated variable. So these ones we're just practicing the translation part. We aren't doing any kind of solving yet. That will come very soon in these problems in the second column. But for right now we're just going to practice. So the sum, we're going to express this given quantity in terms of the indicated variable. So they're already assigning variables for us as well. The sum of three consecutive integers, n equal the first integer of the three. Well, consecutive, that means one right after the other, like 3, 4, and 5. Or, you know, 1001, 1002, 1003. Well, if you think about two consecutive numbers, like 3 and 4, the only thing that separates them is an addition of 1. So if I have my first number as n, then my second number is n plus 1, and my third number is n plus 2. I can't use separate variables for each number because n was the only variable they'll let me use. And I don't really need to because I can express the other numbers in terms of n. Then I want to say the sum of the three. Well, that's easy enough. N plus, I'll go ahead and put parentheses around it for this step. N plus 1 plus n plus 2. And that's the sum. It'll probably take that just fine, but I'm going to go ahead and combine like terms. That is 3n plus, let's see, 1 plus 2 is 3. That is the sum of 3 consecutive integers, where n is the first one. And if n was the middle one, like in problem 8, well then you'd have n in the middle. The one number before it would be n minus 1. The one number after it would be n plus 1. And if you sum those three together, n minus 1 plus n plus 1, and that would just get you 3n. Even integers aren't any harder. If you have two even integers, you know, to go between two even integers, you add 2. Also the same for odd integers. So if I had n as my first one, my next 2 would be n plus 2 and n plus 4. And then you just sum those together. I'm not going to finish, well, I'll write the answer. It would be 3n plus 6. Alright, how about this? Sum of squares of two consecutive integers. Okay, if you sum two things, you're adding them together. The two consecutive integers would be n and n plus 1, and the squares of those would be n squared plus n plus 1 squared. That's fine for the answer. WebAssign should take that. You can expand this and combine those n squared terms if you want, but it's not necessary. Alright, let's do our first problem here. We're going to do the cell phone cost problem. This is problem 22. Alright, a cell phone company charges a monthly fee of $10 for the first 1,000 text messages and 10 cents for each additional text message. Miriam's bill for text messages for the month of June is $38.50. How many text messages did she send that month? Well, if you think about this problem, we have our bill broken up into two parts. We have a $10 we're going to pay any way we do, any way her bill comes out. She's always going to have to pay this $10. But she only have to pay that if she makes less than 1,000 text messages. If she makes more, she'll have to pay 10 cents for each additional one. So, what really determines her bill is how many of these additional text messages she made. So that's the thing I really care about, so that's what I'm going to set my variable to be. Because if I want to find out how many full text messages, then I just add 1,000 to that number. Set my variable to be x, and let's do n instead. N equal number of additional text messages. Alrighty then. So what's her cost function? Her cost equation. Her cost is going to be $10. She always has to pay that. Plus 10 cents for each text message. Well, she has to pay the $10 then. That's just set. And then 0.1, that's 10 cents, times however many of these there are. So 0.1n. And we want to know how many text messages she would have to have made to come up with this $38.50 number for her cost. So we just plug that in for C. $38.50 equal 10 plus 0.1n. Move the 10 over. $28.50 equal 0.1n. Divide the 0.1 out, and I have n equal 285. So we basically solved the problem at this point. We have an answer, but we need to interpret it. How many text messages did she send that month? Well, N is the number of additional text messages. So the total number of messages she sent is actually 1,285 text messages. Because remember, the only way we get charged anything in addition of $10 is if she went over 1,000 text messages. And there we go. That is the answer. 1,285 text messages. We read the problem, assigned a variable, translated into an equation, solved the equation, and then interpreted. As far as checking, I mean, that's not terribly hard to do. Just plug the 285 in. I didn't really on this problem just because it's a pretty simple problem. But I may on later ones. So, next one we're going to look at is 23 here. Lynn has obtained scores of 82, 75, and 71 on her midterm algebra exams. Relevant! If the final exam counts twice as much as a midterm, what score must she make on her final exam to get an average score of 80? Assume that the maximum possible score on each test is 100. Alright, so this is a set of exams, and we want to end up with an average score of 80. Well, how do you average exams? You add them all together and divide up by how many you have. So, my average, 80, would equal... Oh, and I suppose I ought to assign a variable here. So what score must she make on her final exam to get an average score of 80? That's the variable, so I'll let F equal score on final. That's going to be out of 100 because all the tests are out of 100. So 80 equals, we're averaging 82, 75, 71. Now how do I account for the idea, and I have to average the final as well, because it's one of the tests. Now how do I account for the idea that the final exam counts twice as much? Well, I'm just going to count it for 2 exams. So 2 final exams, which would mean my total tests would come out to 1, 2, 3, 4, 5 exams. So the average of 5 scores gets you the 80. So again, we're just setting up an average of all the tests. It's over 5 because the final counts as much as twice a single test. So I just count it as 2 tests. I could write plus F, but that's the same thing as writing 2F. So I'm going to do a few things to simplify this equation. I'm going to clear the fraction, times 5 times 5, and I also will add these things together. So you get 400. Bring up my TI-83 here. 82 plus 75 should be 157 plus 71, which would be 228, I think. Yep. Don't mind me, I'm not actually trying to show off. It's just if I don't practice, I get out of practice. I can't do the arithmetic as quickly. Alright, move the 228 over. That should be 172. Yep. Equals 2f. Divide out the 2. Didn't actually write that. Minus 228. Minus 228. Divide by the 2, you get f equals... that should be 86. 86. Still need to interpret it, though. So what's that? I said f to be the score on the final. That is the score on the final that Lynn needs. Apparently it's a girl. That Lynn needs to get an average score of 80 on all of her tests. On all of her tests. And we've solved it. Moving on.